Alrighty, so what we're having a look at today is factorising trinomials or factorising quadratic expressions. So we might be talking about something like this. X squared plus 5x plus 6. Now if you think about our previous methods of factorising, so we started by looking at common factors. So we looked to see if they had any factors that they shared. So we've got x squared, we've got 5x, and we've got 6. Well, these two share an x. This 6 doesn't really share anything, but what we want is to have this in fully factored form, so everything is multiplying one another. And in that case, we can't do that with one of our previous methods. We can't split it up and group it into pairs. So to do this, we need a special method. Well, actually, what we're going to do to start with is let's look at what something like this gives us. If we expand x plus 1, x plus 2. Okay, now this is our FOIL expansion. Now we multiply our first terms, our outside terms, our inside terms, and our last terms. So we know we're going to end up with 4 terms there, so we end up with x squared plus 2x plus 1 lot of x plus 2, which gives me x squared plus 3x plus 2. Now I hope what you see here is this. The numbers are different obviously, but it kind of looks similar to this. So we're going to employ a similar approach. Factoring, of course, is just the reverse of expanding. So if I want to get this up here into factored form, well, we're going to have to do something similar, and we're going to have to get it into a situation where we have a pair of brackets. Well, here's what we're looking for, and we might do one more expansion just to make sure that we're on the right track. Let's say I've got x plus 5 and x plus 4. And they're grouped together. It means everything's multiplying one another across the brackets. So I end up with x squared plus 4x plus 5x plus 20. Now, what I want you to see is the pattern here. X squared plus 9x plus 20. My numbers inside the brackets here are 5 and they are 4. Now, see if you can find a way that these relate to one another. Okay, well, I hope what you see, and if you're still having a think, maybe pause it right now. But I hope what you see is that 5 plus 4 equals 9, and 5 times 4 equals 20. If we go back to this one over here, 2 plus 1 equals 3, and 2 times 1 equals 2. So what we're looking for is numbers that add to give this and multiply to give this. So what are some numbers that multiply to give 6? Well, I could use 6 and 1, or I could use 3 and 2. Now, if we use 6 and 1, well, we're not going to get 6 plus 1 equals 5. We're going to get 7, so that would be incorrect. So that means that to write this in factored form, we have x plus 2 and x plus 3. That's how we write that expression in fully factored form. We call that a trinomial. It means that tri just means 3. So we have 3 terms here, and can factor that as a pair. You could, of course, expand this out to confirm that that does give you x squared plus 5x plus 6. What if I've got something like this? X squared plus 8x plus 12. Alright, again, well, I'm looking for numbers that add to give this and multiply to give this. So what can I have? I could have 3 times 4, I could have 12 and 1, or I could have 6 times 2. Well, let's see. Which of these 3 here add to give 8? Well, I think it's going to be 6 times 2 gives me 8. So that will be x plus 6, x plus 2. Now, just to clarify, if you put in x plus 3, x plus 4, and you had the incorrect factors, what you'll find is, if we expanded that, what we would get is x squared plus 4x plus 3x plus 12, which is x squared, 7x, and 12. Now what you'll notice is this guy's correct and this guy's correct, but this guy in the middle is wrong. Okay, that doesn't match our 8x that we had in our original question. So that means that even though we've got 2 of these correct, the third one that is incorrect makes the whole thing wrong. So that's why we have to sometimes do a little bit of guessing and checking with these. So 3 and 4 are factors of 12, but they're not factors that add to give 8. So this is our correct factorisation of x squared plus 8x plus 12. Why don't we try one more with a negative number involved? Let's go x squared minus x minus 6. Okay, well the same rules apply, but this time I'm looking for numbers that add to give minus 1 and multiply to give minus 6. Well, if I multiply in 2 numbers together to get minus 6, it means that I could do 3 times 2 or 6 times 1. But all it means is that I'm going to have one of these numbers being positive, so I could have minus 3 times 2 or minus 6 times 1, or I could have minus 2 times 3, or I could have minus 1 times 6. Now any of those combinations there would give me minus 6. But of course only one of those combinations can go together to give me a difference of 1 here, or I add them together and I get minus 1. So let's see what our correct combination is. Well, straight away I think we're going to knock out these two because their difference is too big. So we know we're going to have x, and we're going to have 3 and 2 going somewhere. Well, what I hope you see is that which one is going to be negative? Well, it's actually going to have to be the minus 3, the 3 that is negative and the 2 that is positive. Okay, now the reason is, if we expand this back out, we're going to have x squared plus 2x minus 3x minus 6, which of course takes us straight back up to there, which is what we want. We're not changing this, we're just manipulating this expression. So if we had these two the other way around, plus 3 minus 2, we would end up with x squared plus x minus 6. So a little bit off there. So if we have this middle term being negative there, it means the bigger number must be negative. So I hope that's helped a little bit. And all we're really looking for is the sum of numbers that add together to give that coefficient of x, and then numbers that multiply, or products that give that constant value. And it's okay to have a guess and check. It's okay to make a mistake as long as we are making an educated mistake and actually learning from it.